How's it going, everyone? It's John again. Today I'm going to do a video on more Python programming. If you've been aware of the kind of network buzz, like I've said before, programming and particularly Python programming is very, very hot in networking, so I feel like it's probably worth your while to develop this skill. And because of that, I think it's a good idea to also share knowledge and, well, help each other out, I suppose. So, the basic topology which I've got here is you've got your general three-tier hierarchical model, your core, your distribution layer, and your access layer. Now, right now, nothing's really been configured. The only thing which I've configured is we've got a management VLAN of VLAN 1. Now, I know that's not best practice, but just for simplicity, VLAN 1 is the management, and the IP addresses are going to be for switch 1, 192.168.1.1, switch 2, 1.2, switch 3, 1.3, switch 4, 1.4, so on and so forth, right through to 1.14 for the last switch, which is switch 14. Now, on the left-hand side of our network, at this distribution layer, 3 and 4 will act as DHCP servers, and they will also act in conjunction together to perform HSRP, which will be the first hop redundancy protocol, for which will be our access host, which we've not actually added them in yet, but they would connect to the access switches and use one of these switches as the routers out to the network. So we're going to have HSRP here and DHCP here. We're going to deploy HSRP and DHCP here. The VLANs will be different. On the left hand side, we're going to have VLANs 5, 10, 15, 20, 25, 30, 35 and 40. And on the right hand side, we've got 50, 55, 60, 65, 70, 75, 80 and 85. So essentially switches 3 and 4 will have to have all of these VLANs because they're acting as the DHCP servers and the HSRP first hop for these VLANs. Similarly, on the right hand side, switches 9 and 10, the distribution switches, will also have to have all the VLANs. However, on the access layer, these first two switches will have the first 4 VLANs, and these last two switches will have the last 4 VLANs. The same format on the right hand side. The first two here will have the first 4, and the last two will have the last 4. So that means 5 and 6 will have VLANs 5, 10, 15, 20. 7 and 8 will have 25, 30, 35, 40. 11 and 12 will have 50, 55, 60, 65. 13 and 14 will have 70, 75, 80 and 85. Lastly, once I've deployed that, we're going to automate a general and very basic deployment of OSPF between the core layer and the distribution layer, which is just going to encompass all networks, the quad zeros, area 0. And the reason for that is just to get a quick deployment out. Adjacencies will form because we'll still have this management VLAN of VLAN 1. However, generally what you would do and what I would do would be to, after that, either deploy a different script or manually configure these port to be routed ports so we have just layer 3 access and route between these rather than have actually this is layer 2, but just in the initial configuration, just to pump out quick configuration, we're just using that. And the very last thing which the script will do, it will also perform, or rather it will configure rapid PVSD+. Now here's the thing which you need to watch, see for general automation. Because you're deploying out changes throughout the network and because it's in-band, you need to actually be able to reach all the devices. You need to be careful what you're doing. So for example, if I just go straight here and I change sequentially through 1 to 14, starting from 1, the spanning tree instance. Now think about what would happen there. If I change the spanning tree on this, these links here are going to go down temporarily whilst it reconverges. Once they go down, because this is my gateway to the rest of the network, because I've changed number 1, I can't access 2 now, and because I can't access 2, I can't access any of this, and subsequently I can't access any of this. So what I've actually done, I've actually configured, or rather written, the script to telnet in the reverse for this section. It'll go from 14 all the way, it'll go from the furthest point back to the nearest, so it'll go from 14 into 1. So as to not knock the network out. You actually need to kind of be careful with that. So, with that long kind of preamble, I will say that this script probably is very, very clumsily written. I don't profess to be any kind of software engineer. Definitely not an expert, purely a beginner and just learning this stuff. Hopefully in a year's time or 2 years' time I'll be quite good at this stuff, but like I say, it's just all a learning experience right now. So by all means, if you see this script, you see problems in it, take it, change it, improve it. That's what it's there for. This is just to give people an idea of what you possibly can do if you haven't seen much of this. So I thought I'd put it online for you to see and possibly develop and improve. So I think that's it. I think we'll actually have a wee look at the code. What I will say is that once I'm going through this code, it might seem a little bit dry. You think, oh my god, this is head wasting. Why am I watching this? Understandable. What I will do is, in the comment section of this video, I will just timestamp when I deploy the script. If you don't want to listen to any of that, you can just skip all my blabbering and just go straight to seeing the actual script in action. So I'll do that as well. So I think we'll go and just start configuring this, or rather going through the script. So let's open up our script. Now we've got our basic imports, the get, pass, sys, and telnet lib, and our username is going to be stored in a variable just called user. What's going to happen is I'm going to print the raw input, the welcome IPvZero, please enter your telname username. This will be prompted on the screen to me. What I reply in response to that will subsequently be saved as the user variable, which you can pass in when it's asking for usernames. Now this thing here, this is the get pass module. This is actually very, very useful. It's not good practice to have your passwords readable and clear text saved within your script. The get pass module allows you to get away from that. Essentially what it does is it will just prompt you for a password. Whatever you put in, it is going to save as the variable password, and then you can just deploy it throughout the script. So whatever I enter up here, it will be passed in when it's prompted for password, rather than me actually writing in, oh, my password is Cisco, which in this case it is, just to keep it simple. So the username which I've configured on all the devices is John, and the password is Cisco, and that's pretty much it. So now we've got our general ranges. We've got our, for Z, that's just the variable we're using to save. So for Z in range 1 to 15. Now if you know Python, that basically means that it'll be, I'll just change that up here. For I in range 0 to 15, that's actually going to print up to 14. Actually, I'll change that. That shouldn't be 0. That should be a 1. 1 to 15 will actually print out. I'll leave out the last one. So we'll print I and run that. So we'll go from 1 to 14. Now, why are we doing that? Well, quite simply because that's the range of hosts we have. If we look at the topology again, we've got 1, 2, 3, all the way up to 14. So what I'm doing is saying to telnet into all of these devices, it's going to iterate round through all of these devices and pop in the host. So it's going to be the host will be 192.168.1. Whatever the string of whatever Z is. So when Z is 1, it's going to be 192.168.1.1 and telnet into the host then. When that iterates round to number 2, it'll be 1.2 and it'll telnet into that. TN read until, that's going to be the username. That's because the Cisco device, once you telnet in, it will prompt you for username. Some scripts will say login, Cisco devices say username, so the script will need to actually wait to read username, and make sure you get the capitalization right there because that's actually important. It's got to be spot on as far as I understand. So once the script reads until it sees username, the script is going to write in the user which you gave up here. So whatever you gave up here, in my case, enter your telnet username, I'm going to type in John, it's going to save John as user, and when it types in here, it's going to save whatever I've got here, so I'm going to do user, so it'll be John plus \n. Now \n is effectively a new line, which is your enter key, so that's going to be John enter and enter in. Now we're going to go into global configuration mode, conf-t, and I've just configured some basic commands which can be applicable to all devices, just to give a kind of global change between all devices. No IP domain lookup, and a banner which says this is IPvZero's network, don't change anything, so on and so forth. We're going to exit out and then read everything. So once we do that, we're going to go into the next part of the script, which is going to be for X in range 3 to 5, which means 3 and 4, which means we're telnetting into the distribution layer, which is 3 and 4 here. Once we go into that, we're going to do the same thing. We're doing 192.168.1 dot and whatever the iteration is, which so it'll be 1.3 and then 1.4, telnet in. You'll notice that what I've done, I've actually saved this variable Joe. Now there's nothing special about Joe, it just happens to be the first 2 letters of my name, so I've used that. The purpose of this though is to be able to parse out the last octet whenever, whatever iteration it is. So when it's iterating through 192.168.1.3, I can parse out that 3 and use it as I need it. When it's doing 1.4, I can take out that 4 when I need it and just save it as the variable Joe. So now we're telling it back in, same again, user, if there's a password, read until password, then write in the password, which was again through the getPass module. And now we're going to configure our VLANs. So what we've got here is our TN write from in range 0 to 41.5. What this actually means is go from 0 to 41, which as I've said before, that basically means 0 to 40, and the 5 at the end means skip 5. So we'll be going 0, 5, 10, 15, 20, all the way up to 40. So I'll just quickly show you that on Topology. So in range will be 0 to 40, or rather 41, skip 5, colon, and we'll print, mashing that keypad, let's do that, print I. So if we go here, we'll see we're getting 0, 5, 10, 15, rather than going 1, 2, 3, 4, 5, 6, 7, 8, all up to 40. We're skipping in numbers of 5, which matches again our VLANs. Our VLANs got them 5, that's what we're doing. The next part, what I've done here is I've said if I equals 0 continue. What that basically means is that when it starts as a 0, just skip over that, because effectively what the script is going to do is do VLAN plus whatever the iteration is. So if the iteration is 0, it's going to do VLAN 0. Now, well, if you're a network engineer, you'll know that VLAN 0 you can't do, it's just going to prompt an error. So rather than have that error, if we have a 0, skip over it. So I'll just show you what that looks like again. So if these 2 equal signs, that is for a comparison. So if it's equal to, continue, that means continue over. So if we do this again, we've now parsed out the 0, it's just going from 5, 10, 15, 20 up to 40. So that's the purpose of this part here, the continue. We're going to have our name convention of the VLAN 5 will be called name John VLAN 5, VLAN 10 will be John VLAN 10. Once it iterates to 40, we'll exit out. The next part we'll do is do the same again, just change the variable to y just to make it a bit more readable. If y is 0, continue, so we don't want interface VLAN 0 because we can't have interface VLAN 0. And what I've done here is IP address 192.168, and the third octet will be denoted by the iteration, so that will be for VLAN 5, it will be 192.168.5 dot. And here's the thing here, this Joe thing I was talking about, once we're configuring it for the third switch, we've parsed out the 3 as a variable as Joe, so we're going to pop that in here. So the IP address will be 192.168 VLAN number, switch number. So it's going to be 192.168.5.3 for switch 3, 192.168.5.4 for switch 4. So we can actually have a differential between the 2 switches and they're not just iterating through the same number. Otherwise we both get, I don't know, switch. If we just did 192.168 and used the first usable, well, each switch would also have 5.1, 5.1, 10.1, 10.1. We don't want that, so we're going to have 5.3, 5.4, 10.3, 10.4, 15.3, 15.4, all the way right through. Now we go down to the DHCP part. Down here, it's the same thing. It's basically going to be doing the range 0 to 41, so it's 0 to 40, skip 5, if S, which is the variable this time, is a 0, skip over it. And we're going to do configure terminal and do our exclude the first 15 addresses. So we're going to take the VLAN number as the third octet. So for VLAN, as it iterates to number 5, it'll be exclude 192.168.5.1 to 5.15. And the pool will be called VLAN plus whatever iteration it's on. So if it's on number 10, it'll be VLAN 10. If it's on VLAN 15, it'll be VLAN 15 called. The network ID, the network address will be just the VLAN number in the third octet with a 0 and a /24 mask. The default router, same again, however we're actually going to be using the last usable address. So it's going to be the third octet denoted by the VLAN ID 192.168.5.254, 10.254, 15.254 up to 40. And the reason why we're using 254 is because in our HSRP instance, we're actually going to specify that down there to be 254 between the two distribution switches. So now we move down here again, change the variable to Q just to make it a bit more readable, and it's going to be, oh, 2 seconds, somebody's at my door just now. Sorry about that. Okay, so where was I? Yeah, so the variable is different this time just to keep it readable. So now we are down to our hot standby routing protocol, and it's the same thing for Q 0 to 41 skip 5. It's going to go through the same one, 5, 10, 15, 20 up to 40. If it's 0 continue, do the same thing. It should be the exact same. Now we move down to the access layer on the left hand side, which is 5 to 7, which is going to be 5 and 6. And we're going to have the first 4, so it'll be 5, 10, 15, 20. So if we look at that here, 5 and 7, and we're going to iterate through 0 to 21, skip 5, so it's going to be 5, 10, 15, 20. It's actually going to be 0, 5, 10, 15, 20, but we're actually, if the v equals 0, which is our variable here, continue, so we're going to skip that again. Same thing, same practice, and the process will continue. Same again here, change that variable to b to make it more readable. 7 and 9 is going to be switches 7 and 8, and we're going to use the last 4, so it's going to be 20, 25, 30, 35, 40, so up to 41, skip 5. If it's a 0, that's extraneous, that does not need to be there obviously because it's not going to be 0. I've just left that in because it's been a copy paste. That could be taking out that if v equals 0 continue, because it's not going to be, it's going to iterate through 20 to 40. But I'll leave it there anyway. Now we go down to the right hand side. This is going to be the distribution layer for the right hand side, so switches 9 and 10 as denoted by 9 and 11. We are now here in the topology, so what we've got to do is configure our DHCP and our HSRP. So we do that, and it's the same thing again. It's pretty much the same deal. I'm just going to show you this and scroll through it so you can see it, but it's the exact same thing. It's just the numbers have changed essentially. It's going from 50 to 86, so 50 to 85, skipping 5. Pool, again, the default router is going to be 254 because our HSRP is going to be 254. And now we go to the access layer. For this one, it's going to be 11 to 13, so that's going to be 11 and 12, which is down here. And same again, pop them in the VLANs, first 4 VLANs this time, so 50 to 65. Now we go to the last 2 switches, 13 to 15, which is 13 to 14. And we do the loop for the VLAN range of 70 to 85, the last 4 VLANs. Now we go down to the very bottom, which is our, for O in range, I've just made that the variable O because this is for OSPF. And what we've done is used a list of ranges because essentially it's going to be deployed on a discontiguous number range. So if we look at the topology again, OSPF will be configured on switches 1, 2, 3, 4, which are contiguous, sorry. Then it's going to have a gap between 5, 6, 7 and 8 and go to 9 and 10 and finish. So the way we've done that is to do an actual list. So we do for O in list range 1 to 5 and list 9 to 11, which is essentially as 1 to 4 and 9 and 10, deploy this script on them. And what we're going to do is do the router ID. I'll say this as well actually. As the letter O, the variable O, iterates through from 1, 2, 3, 4, 9, 10, we're going to be able to assign that to a variable called num in this case. And the purpose of that is to have a distinct number for each router so that each router can have a unique router ID. And the way that works is because when O is, say for example, 1, it's going to grab that 1 and make it num. And when it comes to the router ID, we're going to do num, which is going to be 1.1.1.1. And when the script iterates to number 2, O will be 2, so num will be 2, so the router ID will be 2.2.2.2, right up to when the script iterates to number 9, O becomes 9, num therefore becomes 9, the router ID is going to be 9.9.9.9, so they're all different. Then the last thing we're going to do is, like I said, this thing about the reversed range. So rather than go from 1 to 15, which is 1 to 14, we're going to go the reverse range of 1 to 15, which is going to be 14 counted down to 1. So we're going to telnet into 14 first, username, password, do spanning tree mode, rapid PVSD, and exit out, iterate back round. Now we're going into 13, do the same thing, rapid spanning tree mode, PVSD plus, iterates down to 12, spanning tree mode, rapid PVSD, down all the way to 1, and then the script finishes. And then that's pretty much it. That's all the changes done. So after all that, I think we should actually go and deploy the script. So let's have a look-see. Just for posterity, I'll just show you that I don't actually have any configurations on this. Show, run, all we've got is our trunk, link, and 1.1. Grab another one, 14 for example. Show IP int brief. All it's just got is the management VLAN. Show standby brief, doesn't have anything. Show run, no DHCP, nothing. Well, that wouldn't have DHCP on it anyway because that's just an access switch. But if I grabbed, what's one of our, number 3 is one of our distribution switches. So it did a show run here. Nothing on that. It's just got its IP address and its telnet access. So with that, let's go and grab this script. So we'll Control A to grab it all, and we'll copy it. And what we'll do is we'll go on to the host, which is IPvZero, and close you down. And ifconfig just to see our IP address. So we are on the last usable address within the management VLAN range, which is 1.0, so we are 1.254. And what I'm going to do is do a nano and just call the script IPvZero.py. Just copy this in and we'll write it out in X. Okay, so let's full screen this and I'll just do Python IPvZero. Prompt me for, well, welcome IPvZero, please enter your telnet username. So it's John in this case. Password, this is the get pass module. Cisco, and now we're configuring all of the banners globally. Next it'll go to switch 3 for the distribution switch, do our DHCP and our HSRP. That's switch 3 done, switch 4's next. And then it should go into the access layer on the left hand side, the first 4 for the first 2 and the last 4 for the last 2. And that's us there, first 4, last 4. Now we go to number 9, which is going to be the distribution layer on the right hand side, DHCP and HSRP, all that stuff. And then number 10, DHCP, HSRP, all that stuff. Then the access layer on the right hand side, which is going to be the first 4 for the first 2 and the last 4 for the last 2. So number 10 should come through now. There we go. And the access layer. Now we go into OSPF, the router IDs and all that stuff. 2.2.2, 3.3.3, 4, 9, 10. And the rapid spanning tree going back to front. and that's the script finished. So that's all that was. That's how quickly it could be done. That's how easily it was deployed. So if we do, for example, show stand brief, we've got our HSRP, that's number 3. They're all 35.4 for the active ones. This means this is the active one right now. And we go on to show stand brief. Standby is a 3 one. If we go to, that's our OSPF up as well. If we go to, say, number 9, just do a show run generally. We've got all our DHCP excluded addresses. We've got all our interfaces up, banner. Let's go to, I don't know, show IP OSPF neighbor. We've got our router IDs, all the 1s, 3s, 4s, so on and so forth. Go here, show IP protocols. You can say that's router ID is 4 for number 4. Show IP int brief. If we go on to say number 9, show VLAN. We've got our VLANs there, all of them. What have we got for number 12? Number 12 should have 50, 55, 60, 65, I think. So if we go to number, and we do a show VLAN. Yep. And again, if we do our wee exit out that, we see everyone's got this banner. This should have the last 4. Yep, up to 85. Again, exit out, back in, see the banner, and that's been applied globally. No IP domain lookup, of course, globally everywhere as well. Yep, so I think that's the end of the video. I just thought I'd just show you just how quickly things can be deployed with Python. Like I say, the script is definitely not perfect. If you can improve it, by all means, go so and do so. I thought I'd just pop it up just so people can get some kind of idea of just how quickly you can scale this stuff, and because it comes fast, and well, because it's fast and because it is because it's automated basically, because of that, mistakes are less likely to happen because it's very, very sequential. It's like DHCP, it'll just go through it sequentially rather than you actually trying to type in everything manually and making it unnecessarily difficult. So, yep, I think that's the end of the video. I'll probably do one in another week or so on Python, maybe make another script, maybe a bit more in depth. But that's the end of this one, and yep, so that's it. So I'll see you guys soon. Thanks very much.